How do I turn this thing on? What the? Oh, okay. So we gotta record a video. Hello, everybody. Welcome to IT Security Labs. And today we're going to be learning how to bypass Applocker restrictions in Windows. This video is for ethical hacking and is supposed to be used in legal ways only. So if you're interested in learning how to become a better pen tester, red teamer, or just get started in cybersecurity and hands-on labs, join me in this path. I'm learning these things, and a few months ago I spent some time learning the OSEP and I passed the exam. And that's where I learned these tricks here where you can bypass restrictions that are usually enabled in the enterprise during pen test. So how do we do that? And what is Applocker and how does it work? If you go to the Windows documentation, they say Applocker helps you control which apps and files user can run. These can exclude executable files, scripts, Windows installer files, dynamic libraries, and so forth. So in most environments, especially in the enterprise, Applocker is going to be enabled, blocking applications that are not signed, maybe some scripts like PowerShell and things like that from the user. And that's what I have here. In my lab environment, I have a Windows machine. That's a victim. This one is Applocker enabled. We can show you here that if you go and try to run a PowerShell script, so let me go in here and say, I just open PowerShell and I have a PowerShell here called shell.ps1. If I run it, not only in this case, it's also being blocked by restricted mode. So let's do something like set-execution policy but to bypass. Say yes. Oh, we can't do that because access to that registry is blocked. What's happening here is because Applocker is enabled. And if you go here, this is where Applocker is enabled. So it allows for scripts administrators to run, and everyone else can run scripts from these other locations here. So this is the default Applocker. But as you can see, I'm running it from the desktop. So this is not going to work. And that's why we're having problems here. So what can we do? We're not an administrator, so we cannot just run scripts from anywhere here. Well, first, our victim also has email. As you can see, they can receive emails. So I'm going to send them an email as an HTA file, as a link, and then we'll see if they can click on it. If they click on that link, it's supposed to automatically execute my PowerShell script and I can get a reverse shell. So coming down here, here are the steps that we have. Generate a PowerShell payload. Compile it with Applocker bypass so that we can actually run it. Encrypt it with setutil. We encrypt the compiled Applocker bypass with setutil so that Google Chrome and even Windows Defender do not do that static analysis and find out that, this is actually a loaded file with an executable. So we encrypt it into a text file. Then we will create an HTA file to deliver that to the victim because the victim needs something to click. And you can use an LNK file, an ISO file, PDF file here on step number 4. I just chose HTA because I want to test out my email client there. Then we can use SWACs. This becomes helpful for the OSCP, OSEP kind of exams where you need to email someone. So something like, hey, Bob in HR usually clicks on emails, and somehow you find out that Bob is also, Bob's email is posted somewhere. You also find out that there's a mail server in that environment. So you email Bob in HTA file and boom, you profit. So let's do that. First, generate payload. To generate our payload, let's just go to refshells.com. And on refshells.com, I went here and I chose Windows. And I went to PowerShell. Then I gave it the IP address of my Kali attacker machine, which you can do an IP8 find. Then I gave it port 444. And here it gave me a PowerShell that I'll be running. So I can copy that. I also need to use Netcat here as my listener. But this is my payload. This payload needs to be saved in a file called shell.ps1. So let's go to Kali. Say nano shell.ps1. Paste it in here. Save. Now we have shell.ps1. Step 1 done. Step number 2, compile Applocker bypass, because this is the secret, super secret. If you send shell.ps1, you will face what we just saw here. You need to go to GitHub. Chaz here, I give him all the credit here, has an Applocker bypass shell. Please go ahead and check out his GitHub, and also he has a blog post you can find a link for. Great. So I think it's Chaz. I might be butchering his name, but here we have a Applocker bypass. So you want to clone this to a Windows development machine that you use for malware development. In this case, I'm using Commando. I cloned this entire repo, went to this folder, and I need to edit this project. So let's go here. You notice that I'm already in here. I cloned it to my desktop. And this is it. And I just opened this project. And it opened it right here for me in VS Code. In Visual Studio. So once it opens, all I did was I added this line here. String command. I even left the right console the same way. So what did we add here? We want to run a download string to our Kali Linux machine. And in this case, it's pointing to shell.ps1. So this line here will download our shell.ps1 and pipe it to IEX and execute it immediately. So if anyone clicks on this executable, it will pull the secondary payload. So that's how this is going to work. And then, of course, it's going to be using PowerShell the entire time. And PowerShell, as you can see, as you saw, is restricted. And that's what we have. So now that we have this, we can go and build the project. Build the solution. You notice that mine has already been built. If we go to the folder in bin release, here's my Applocker bypass. Notice that I built it with release and any CPU. So copy that file on my desktop on this machine, then open command prompt, then we go to desktop. And I have Applocker bypass.exe here. That's the same. I just renamed it so that it doesn't have spaces. But I have Applocker bypass.exe on the desktop. You can use setutil from anywhere. But now that I have it on my desktop, I need to use setutil. So let me show you. So step 1, we generate our payload. Okay. Now setutil, we just say, hey, setutil, can you encode that into a different file? So we'll say, in this case, we said enc.text. So watch what happens. So here we need to change one thing here. Mine is just called Applocker bypass. Okay. So now that we have Applocker bypass command here ready to go, we just go and fire. Okay. So here we're now using setutil to encode Applocker bypass.exe so that this just bypasses, static analysis. So type enc.text. It's just a text file that looks like this. So this might be a little harder for Defender to see. Just another step to add there. Now that we have our enc.exe, we need to move on to the next step, create an HTA file. So what is going to happen here? Notice that I already have my HTA file here, and we're saying, hey, PowerShell, can you download? In this case, we need to give it our IP address. This is going to be the IP address of our Kali machine. So IPA. And in this case, 172.16.0.25. Okay. And we now know that our file is called enc.text. So we need to change this to enc.text. All right. And we need to make sure that it's available on our Kali as well. Okay. So going to our Kali, here's our enc.text. So you need to copy it from your development machine into Kali in a folder. Okay, so our enc.text is here. This is our encrypted file. Our shell.ps1, this is the one that we want to call. And our enc.text is going to call shell.ps1. And once it calls shell.ps1, it will immediately execute it. So all the victim has to do is click once and we get a reverse shell. That's here how this is going to work. Okay, next we need to send an email to the victim, but we don't know what the email address is. In most cases, you'll find this on the website or somewhere else. In this case, I'm going to show you. We have admin at itsecurity.lab.thm. So that's the victim that we're going to be targeting here, this admin user. So we also know that there's another user here called Adam you have found this during enumeration, but I want to save us some time here. This admin needs to receive an email with our HTA file. So we send the phishing email using SWAX. This is a tool that you can use if you're going for CTFs like OSCP, OSEP, and you see that you need to send someone an email, whether with an attachment or with a link, which is very common. So we use SWAX, which is already installed on Kali. We send them an email that says, please click here, and notice that this is just our file. But we don't send them the malware first. We send them an HTA file with just ping to see if ping works, because if you send the payload first, you don't know whether the payload is the one that got caught and didn't execute, or even the victim is even clicking. So first we'll send the ping.hta, and I'll show you what that looks like. And here we're just specifying the regular usage of SWAX with the headers, and our message is issues with email to the admin from a user called Adam. This ensures sometimes that it makes it over there. And the server, we specify the server that we saw in our scanning. So if you are doing a CTF, you'd have seen a mail server with port 25 open, and that's what you specify there. All right. Notice that we are sending a ping.hta. So let's go check out what's in ping.hta. You need to create this as well. So cat ping.hta. Notice that instead of running our file that downloads our payload, we're just going to say, hey, ping 4 times to our Kali machine. Okay, so that's what we're going to try right now. So how do we do that? We can say, in this case, Python 3 -m HTTP server right there. And then we also need to run TCP dump on ETH0. So if I do an IPA, ETH0 is this network that we have this IP on. So let's run TCP dump. This is going to listen for ICMP traffic. So when we send our phishing email, if the victim clicks, we get pings back. And pings are usually harmless, and they're allowed sometimes. So this will show us whether the victim clicks or not. And next, we have that loaded. Let's use SWAX. And send. I just said something. Let's go to our victim. Here is a new email. It says issues with email right now at this time. So the victim downloads the email and clicks on the link. I actually wrote a script here that clicks on links. So let's run the script, assuming that I will send this lab and share it with everybody in the future. So if I run this script here, the victim clicks on the link. It opens, a browser. In this case, our HTA is being flagged, but hopefully we find a way to bypass that. We can say keep, and the victim clicks on it and runs it. Notice that pings are working. And if I come back here to my TCP dump, I see that ping worked. That's how you verify. Before you send any real payloads, make sure to send pings first. Now that we have a ping working, we can feel comfortable in sending our own HTA. In this case, we would have saved it as run.hta. Let's get run.hta one more time. Quick reminder, this is actually a little bit more complicated than what we did last time, but let me explain, and I'll share this with you as well if you want. We're actually running PowerShell to download our encrypted file. In this case, this is not going to work, so we need to change our file IP address here. But this will download the encrypted file and save it in Windows tasks. So we like to write there because most of the time, most people can write into this folder. Then we use PowerShell with setu2 to decode that file into a file called run.exe. And run.exe has the bypass option. And the bypass option needs to run with this .NET Framework 64 version. And every Windows machine has it. It's the uninstall service. And I'll post a document here that explains how the uninstall service works so that you can spend more time reading about it. But after we use that to run our decrypted run.exe, we should get a reverse shell because run.exe is a UAC bypass that calls our PowerShell reverse shell. Okay, so now that we know that what's in run.exe run.hta, all we need to do is host our server as usual. Go back here. Instead of sending ping with our swag, we're going to send them run.hta. And this will ensure that everything actually works correctly. So here, instead of ping, I like to run run.hta. Boom. I hear the victim got the email. If we check here, they got the email. I'm going to use my script here to automatically open the email. They get run.hta. They run it. In most cases, you can hide this one as well. But for now, let's go back to our attacker. We're listening. See, we got run.hta, and now we need to wait for it to come back for shell.ps1. Okay, I forgot something. I mentioned it, then I didn't change it. Okay, so here, nano run.hta. My run.hta needs to point to my actual IP address. In this case, this is going to be 172.16.0.25. So I will not edit this so that you can see that mistakes still happen and we need to know what we're doing to fix them. Okay, so now that we did that, also point we're using double here just to make sure that, you know, we escape just in case Windows doesn't read it correctly. Okay, now that run.hta is fixed, let's host it again. Let's start our listener if it's not already starting. Good. And then let's resend the email. All right, victim gets the email. We know that they download the email, and in this case, we actually want to get a new copy of run.hta. Let's do it again. Victim clicks on the email, gets run.hta, runs it. It opens PowerShell. We can hide this as well, but for now, since we're just practicing, notice that it's actually running PowerShell. Here's the decryption happening in the background. I wanted you to see this, but there's a silently continue, or you can even hide a flag. So going back here, notice that we got a reverse shell. That was quick, but here are the steps. You download the file.hta, which is an encrypted file. The encrypted file got decrypted, called PowerShell, and PowerShell now code back here on port 444. So we know that we have a reverse shell here because when I hit enter, I can say get UID. I'm already vagrant. Who am I? Would be the command. So the machine name is ra, as you can see. If you go back, let's just finish in PowerShell. Host name ra, and we're running in as vagrant. So those are the steps, everyone. If you're interested in this stuff, please let me know in the comments below. Like, subscribe. These videos take an effort, and you need to let me know if this is even worth spending the time. Otherwise, thanks very much. I hope you share this video, and I will see you next time. Thank you.